Welcome to this course on beta and gamma functions. I'm Suman Matthews. I am a math educator teaching math for over 2 decades, and I have tried to simplify beta and gamma functions for you in this course. Here we talk about beta functions, my first lesson. Now, this is a useful part in college mathematics, and students who are taking maths as their major will come across beta functions. So, what is a beta function? A beta function is a function in two variables, beta mn, and it is integral 0 to 1 x raised to m minus 1, 1 minus x whole raised to n minus 1 dx, where mn are greater than 0. So if I put x as sine squared theta, dx will be 2 sine theta cos theta d theta. Now when x is 0, theta is 0. When x is 1, sine theta is 1, so theta is pi by 2. So beta mn becomes integral 0 to pi by 2 sine squared theta raised to m minus 1. 1 minus sine squared theta is cos squared theta raised to n minus 1. Dx is 2 sine theta cos theta d theta. That is twice integral 0 to pi by 2 sine raised to 2m minus 1 theta cos raised to 2n minus 1 theta d theta. So this is your beta mn. You can also write it as integral 0 to 1 x raised to m minus 1 1 minus x whole raised to n minus 1 dx, or twice integral 0 to pi by 2 sine raised to 2m minus 1 theta cos raised to 2n minus 1 theta d theta. Now what's a gamma function? Gamma function is equal to integral 0 to infinity e raised to minus x raised to n minus 1 dx, where n is greater than 0. So if I put x equal to t squared, dx is 2t dt. When x is 0, t is 0. When x tends to infinity, t tends to infinity. So this is integral 0 to infinity e raised to minus t squared raised to n minus 1, 2t dt. That will be twice integral 0 to infinity e raised to minus t squared t raised to 2n minus 1. 2n minus 2 plus 1 will give you 2n minus 1 dt. So this is another way of writing the gamma function, twice integral 0 to infinity e raised to minus t squared t raised to n minus 1 dt. So we have the properties. Beta mn is beta nm. For that, start with beta mn, which is integral 0 to 1 x raised to m minus 1 1 minus x whole raised to n minus 1 dx. If I put x as 1 minus y, when x is 0, y is 1, and when x is 1, y is 0, and dx is minus dy. So this becomes integral 1 to 0, 1 minus y raised to m minus 1, y raised to n minus 1 minus dy. So when I revert the minus sign, it becomes integral 0 to 1 y raised to n minus 1 1 minus y whole raised to m minus 1 dy, which is your beta nm. Then you have another property of the gamma functions. Gamma n plus 1 is n gamma n. Now gamma n is integral 0 to infinity e raised to minus x raised to n minus 1 dx. What is gamma n plus 1? Integral 0 to infinity e raised to minus x, this becomes x raised to n dx. That is integral 0 to infinity x raised to n e raised to minus x dx. So if you integrate by parts, taking x as the first function, it is x raised to n integral 0 to infinity e raised to minus x dx minus integral 0 to infinity n x raised to n minus 1 minus e raised to minus x dx. So minus minus will give you plus. So when you integrate, you get x raised to n e raised to minus x by minus 1 within the limit 0 to infinity. Take out the n plus n integral 0 to infinity x raised to n minus 1 e raised to minus x dx. So when I substitute the limits, it becomes, you get 1 by infinity is 0, and this is n gamma n, because gamma n is integral 0 to infinity x raised to n minus 1 e raised to minus x dx. So we have proved that gamma n plus 1 is n gamma n. Now if n is a positive integer, gamma n plus 1 is n factorial, because we start with gamma n plus 1 is n gamma n. Now what is gamma n? N minus 1 gamma n minus 1. What is gamma n minus 2? N minus 2 gamma n minus 2. So going on so far, you get n into n minus 2 up to 1, which is n factorial. Then beta mn is gamma m into gamma n by gamma m plus n. What is gamma m? You can write it as twice integral 0 to infinity e raised to minus x squared x raised to 2m minus 1 dx. Now what does this do? This relation gives you a connection between the beta function and the gamma function. And gamma n is twice integral 0 to infinity e raised to minus y squared y raised to 2n minus 1 dy. Gamma m plus 1 will be twice integral 0 to infinity. I am taking the variable as r because we have already chosen x and y. So it is e raised to minus r squared r raised to 2 into m plus n minus 1 dr. So gamma m into gamma n will be 4 times integral 0 to infinity using the law of indices e raised to minus of x squared plus y squared x raised to 2m minus 1 y raised to, it should be 2n minus 1 here, dx dy. So that will give you, if I put x as r cos theta, y as r sin theta, this is polar coordinates, x squared plus y squared is r squared, dx dy will be r dr d theta using Jacobian. Now r lies between 0 and infinity and theta lies between 0 to pi by 2. This we had seen when we on my earlier video on Jacobian. So gamma n will be 4 integral r varying from 0 to infinity, theta varying from 0 to pi by 2, e raised to minus r squared, x becomes r raised to 2m minus 1 cos raised to 2m minus 1 theta, y becomes r raised to 2n minus 1 sin raised to 2n minus 1 theta, r dr d theta. So we can split the integral and write it as twice integral 0 r varying from 0 to infinity e raised to minus r squared r raised to 2 into m plus n minus 1. So I am taking the terms in r as with one integral and theta with the other integral, and 2 integral theta varying from 0 to pi by 2 sin raised to 2n minus 1 theta cos raised to 2m minus 1 theta d theta. So this is your gamma m plus n and this is your beta nm. Because gamma n you can write as twice integral 0 to infinity e raised to minus x squared x raised to 2n minus 1 dx. And beta nm you can write as twice integral 0 to pi by 2 sin raised to 2m minus 1 theta cos raised to 2m minus 1 theta d theta. So we get gamma m into gamma n is gamma m plus n into beta mn, or beta mn is gamma m plus n by gamma m into gamma n. Next, we show that gamma 1 is 1. What is gamma 1? Twice integral 0 to infinity e raised to minus t squared t raised to 2 into 1 minus 1, that is t dt. That is twice integral 0 to infinity, integrate by parts taking t as the first function, or you can make a substitution first, put t squared as u, so 2t dt is du. When t is 0, u is 0. When t tends to infinity, u tends to infinity. So this is integral 0 to infinity e raised to minus u du, because 2t dt is du. When you integrate, you get e raised to minus u by minus 1 within the limit 0 to infinity. 1 by infinity is 0. So I get 0 minus minus plus 1, which is 1. So gamma 1 is 1. Next, we show that gamma half is n factorial. Now gamma n is twice integral 0 to infinity e raised to minus x squared x raised to 2n minus 1 dx. So what is gamma half? Twice integral 0 to infinity e raised to minus x squared x raised to 2 into half minus 1, which is 0. So this can also be written as twice integral 0 to infinity e raised to minus y squared dy. So gamma half the whole squared you can write as 4 times integral 0 to infinity integral 0 to infinity e raised to minus x squared into e raised to minus y squared, that is e raised to minus of x squared plus y squared dx dy. Again, as we did in the previous problem, put x as r cos theta, y as r sin theta, r lying between 0 to infinity, theta lying between 0 to pi by 2. So dx dy is r dr d theta. So this is 4 times r going from 0 to infinity, theta going from 0 to pi by 2 e raised to minus r squared, r d theta dr. Now if I put r squared as t, 2r dr is dt. When r is 0, t is 0. When r tends to infinity, t tends to infinity. So gamma half squared becomes 4. Theta will be the same, integral 0 to pi by 2. R will be within the limit 0 to infinity e raised to minus t dt by 2 d theta. And now when you integrate, you get 4 times integral theta going from 0 to pi by 2 e raised to minus t. Actually, the 4 cancels with the 2 here, and you get e raised to minus t by minus 1 within the limits t equal to 0 to infinity. So you get 4 times, this will be 1 by infinity is 0, so I get this becomes 0 minus minus plus 1 by 2, and the 2 cancels with the 4, and again when you integrate theta, within the integral of d theta is theta within the limit 0 to pi by 2, you get the final answer as pi. So what have we seen? That gamma half is in fact is pi. So gamma half the whole squared is root pi, or gamma half is root pi. So gamma half is actually root pi, not n factorial. Please make the correction. Gamma half is root pi. So that is what we have proved. We have shown that gamma half equal to root pi. So take a pen and paper and practice every line along with me, and do let me know if I can help you in any way. Thank you.